Okay, welcome back, kiddos. Now we are moving on to 8.2, talking about proving triangles similar by AA, SSS, and SAS. All right, so if you recall from our last lesson, we talked about similar triangles, which are, what did we say similar was? Similar meant same shape, but a different size, right? So that's what we call a dilation. Okay. Same shape, but a different size. That's what we're talking about over here. So how can we prove that? That's what we're going to talk about today. So these may look similar, but how can we prove it? Okay, so we're going to have three theorems that we can use to prove that these are similar. All right, so the first one is going to be AA, okay, which stands for angle, angle. Okay, so if two pairs of angles are congruent, so if we look at these two, this says this one and this one are congruent, right? Then this one and this one are congruent. So that's the first set, right? That's number one. Okay, that's number two. If we know that both of these are congruent, this one has to be congruent with that one. Okay, that one has to be congruent with that. So if two pairs of angles are congruent, then the third angle should also be congruent. Okay, so if we know two of them are congruent, then we're going to say we can prove it by AA. Two of those are congruent angles, then we can prove it. All right, next is side, side, side. We're going to label that SSS. Okay, so if all three sides are proportional, then they are similar, right? And we talked about setting up those proportions last time, right? So if we have something equals something, if that is true, then we know that they can be proven by SSS. Okay, that's the second way. Then the third way is going to be SAS, which is side, angle, side. Okay, so if we know that, for instance, this side right over here and this side are proportional, right? And then this side and this side are proportional. If this angle is in between, it has to be congruent, including those two sides. We'd say side, angle, side. So if this side number one was congruent with this side over here, right? And then if say that's side number two and then side number two, not congruent but proportional, and this angle in between is congruent, then we could say side, angle, side, side, angle, side. All right, so those are the ways that we can prove it. Either angle, angle, which means all three are the same, side, 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 where they're all three proportional, and then side, angle, side. Okay, so let's take a look right over here, and we're going to see if there's enough information to determine if they are similar, and if they are, how do we know? Okay, so let's take a look over here. All right, so for this also, we want to make sure that we pull up our calculator. So pull up your Desmos on a split screen real quick. Pause and do that. All right, so we want to see if these are two similar. All right, so let's look at what we have. We said we have a side, an angle, and a side. Right, side, angle, side. So if these are proportional, then they are similar. So let's find out. Okay, so we have to set up a proportion. So we're going to see if this is true, right? That's what we're asking ourselves. Is this true? Would this be proportional to this? So let's look over here. So let's start on this one. Since this is the left triangle, let's look over here. So let's just put 25 over there. Okay, now what would correspond with 25 over here? Well, if we see the 38 in the middle, 25 is on the left side. So 30 is in the middle, 125 is on the left side, right? So that would go there. So then, if this is the left triangle, what would go over here would be 31, right? And then, this is on the right side of that 38, right? So on the right side of that 38 would be 155. Okay, so now here's what we're asking ourselves. Is this a true statement? Is this over this equal this over this? So we can do two different things to find out. Okay, so let's go and type that into our calculator. So let's go and push that division button first to make a fraction. Okay, let's type that in. 25 on top. Okay, then go to the bottom and put 31. Okay, so we have this value right over here. Now, this is what I really like about Desmos. I can keep that there and just as a guide, and let's do the next one. So let's put this into there. So let's put that division button. Let's put 125 on top. Okay, go down below and put 155. Okay, and we're asking ourselves, are these the same? Is this equal to this? And the answer is yes, they are the same. So they are similar because we can say side, angle, side. Side, angle, side. So yes, they are true. Okay, now a different way we could have done it is seeing, okay, let's cross multiply, right? Just like we did last time, right? So we'd say this times that, 25 times 155. So let's put those into our calculator, right? So 25 times 155, okay, is equal to that. Let's see if that's equal to this times this, right? 31 times 125. So 31 times 125. And as you might imagine, they are equal. So that's a true statement. However I did it, if I wanted to see if this side reduces to the same as that, as we just did right up here, okay, or if I want to cross multiply. So either way, if it's a true statement, then they are true. Okay, that's it. So keeping that in mind, see about this one. Okay, they once again they want to see if these are similar or not. Okay, so what did we say? We see two angles here, right? So we said if two angles are congruent, that means all three actually have to be. So let's look over here. We have a 45. Right here we have a 45. Here we have a 104. There we have a 104. So that is AA. So yes, those are similar by AA property. All right, next, let's look over here. Are these both similar? Okay, well, let's look. We have three sides, right? Side, side, side. So we want to see, we said we could tell if they are all proportional. Actually, so let's do this. Actually, we want to see like that, right? So all three pairs are proportional. So let's check it out. All right, so on this first one, let's look at this. All right, so let's look at the smallest number. That's one way to look at it, right? So the smallest one obviously is 9, right? So we want to see if 9 over the smallest over here, right? So the smallest is 45, right? We want to see what that reduces into, okay? And we want to compare it to these other ones. So let's do the middle one, right? So the middle number would be 12, right? So 12 over, what's the middle one over here? That would be 60, right? Okay, now let's do the last one. So the last one would be the largest one, right? So 14 over, okay, what's the largest one over here? 70. Okay, so now what we're going to do is we're going to type these into our calculator. If the numbers I get over here, here, and here are the same, that means they are proportional. So let's go and type that into our calculator. So let's get rid of all this stuff right here. All right, so let's start by putting our division button. So I'm just going to put 9 over 45. So 9 on top and 45 on the bottom. So that gives us 0.2. Okay, so let's check that other one. All right, so actually, let's do this. Let's push that fraction button. So fraction is 1 over 5, right? So this is 1 over 5. Okay, let's do this. 12 over 60. Same thing. I'm going to put division button. Do 12 on top. I'm going to do 60 on the bottom. Okay, I get a decimal. Getting a decimal, so I'm just going to push that button, and it tells me it is still 1 over 5. If you noticed here, I had that 0 in front, but 60 is the same as 60, right? Next, okay, do the same thing, except for with this last one, 14 on top and then 70 on the bottom, right? So 14 on top and 70 on the bottom. What do we think? That one is also 0.2, so we know it is, once again, 1 over 5. So, these are all proportional. So yes, they are similar by SSS. Okay, so all the sides are proportional. Okay, so that's what we did is we just set up those ratios and checked it out. Okay, so then let's go to our last one. Okay, it says determine if these are proportional or not. So let's take a look. This one's going to the next level. Okay, so let's look at these numbers. We have a information. We have an angle, side, and angle, right? So what do we have over here? Actually, we have a side over here too, right? So this one we have two angles. This one we have one. So the only thing we can do is we can't do angle angle on this one, right? We can do we and we don't have three sides, so we can't do side side side. The only one we can do is side angle side, right? So let's see if these are true, right? So first off, is the angle the same? Yes. Okay. Next, we need to see if everything is proportional, right? So let's look over here. So 32. We need to see if that's proportional with what? What would go? Oh, actually, let's do this backwards. Sorry. Since 30, this is on the right side. Let's put 32 over there. Okay. Now, what would be over here? What number? Okay. Well, if 47 is pointing up, 32 is on the left. 47 is pointing up, 16 would be right there, right? Okay, so now what would be the value over here? Okay, we had 32 on this one, so we're going to have 36 over here. Okay, what would correspond with 36? Would it be 13 or 17? Well, the 36 is on the right side of that 47, so that would be 17. Okay, so now we're asking ourselves, is this a true statement or not, right? We said if these are proportional, then we could say, if these are proportional, then we could say that it is side angle side, right? They have to be proportional, okay? So let's take a look. Type it into our calculator and find out, right? So let's get rid of all this stuff. All right, so I'm just going to type in 16 over 17, okay? And see what that fraction is. It's still 16 over 17. And then I'm going to put 32 over 36. Okay, push that and ask myself, are those the same fraction? 16 17ths and 18 ninths? No, those are not the same, right? So the answer is no, because it's not proportional. Okay, so that's the gist of it right there. All right, so these look similar, right? These look similar, but maybe they are, maybe they're not. The only way we can prove it is if two angles are the same, then we know they are similar, right? So that's what we said right here. If sides are all proportional, so we have to find the proportion from one to the other, one to the other, one to the other. If they're all the same proportion, yes, they are similar. Or if we have a side and angle that's the same in between and then the side. If the angles are congruent, then we need to see if those other two, the sides, are proportional or not. Okay, so that's how we find out. So go ahead and do these practice problems first before we go on to the other side. All right, so now we're going to the home stretch on this last step. So make sure you did the practice on the first side first before you do this. All right, now we need to show that these are two similar runs, triangles, right? So which one of these three can we use to say that? All right, well, one thing is we notice that these are two different triangles, right? I have one that looks like this, right? And then a smaller version of it, right? So we have like this one right here. Okay, and then I have a smaller version of it right there. Okay, so we got two triangles. Now, let's look at the information. So we see this and this. This tells us that these are both parallel, right? That's what that tells us. So we're putting all our information together, right? What if those are parallel? Then we can think if these are parallel lines cut by this transversal, then this angle is equal to that angle, right? This one has to be equal to that. What else do we know? We know that this angle has to be equal to that angle, right? Because if these are parallel lines cut by that transversal, these angles are the same. So if this angle is the same and this is the same, we have A, right? So that's how we prove that one. That's by A. All right, next, keeping it moving. Keep it moving. Let's look over here. How can we prove this one? Okay, so we have two triangles here, right? This is one triangle. Right, and then this is a different triangle. Okay, so we want to prove that these are congruent. Well, what does this tell us? This tells us that these are parallel, right? So if I imagine these are parallel lines cut by this transversal, right? That means this angle is equal to this angle, right? Then we know that this side, they share that side, right? Now, what do we know about this? Is this side equal to this? They may be, but we don't know that for sure. Okay, so we can't say that. But what we do know is um, this is also parallel with this. So if these two lines are parallel, right, this one is parallel with this one, and it's cut by this transversal, then that tells us that this angle is equal with this angle, right? So then if we have an angle and an angle that are the same, that means that third angle is also the same. So that's enough to prove it. Angle is enough to prove it. Okay? All right, now let's keep it moving. What about this last one? This tells us that these two triangles are congruent, right? So we have two triangles. This one right here, SVR, and then UVT, UVT, right? Those two. Okay, so what do we know? Well, we do know that this angle is equal with that angle, right? Because those are vertical angles. Okay, then also, if this line is parallel with that, right? That's what that tells us. Then if we have these parallel lines cut by this transversal, right? Then we know that this angle right here is equal to this angle right over here, right? And so then if we have let's actually do 2 marks right there to delineate that. So then if I have this angle is equal to that, and this angle is equal to that, that means that's enough. That's A, right? That's enough information right there. Okay, so that's how we could prove that these three were all the same. These just happen to be all angle was enough. All right, so now, keeping all that information together, let's put it all together. All right, so it says, given that these two triangles are congruent, are similar, JKL, right? JKL, so this one and M and L. Enter the segments in the blanks that would result in the true equation. So this is NL over ML. All right, so let's look. NL. NL is this one right here. So that's this triangle. Okay. So over here, what would correspond? Whenever we have it like this is the way we can tell. The one that corresponds is going to be on the other side. So this one right here. Okay, so that's going to be LK or KL, right? So LK. All right, so now that we're getting the hang of this, let's think about the other one. This is ML. So ML would be this one right here. Which segment do you think, given I told you these two, what do you think is similar with that one? It would be this this one right here. Okay, so that would be called JL or LJ. Okay, so that's how we do it. Whenever we have these two lines that cross, okay, we know this angle is equal to this, and so this one is similar with this, and this proportional with that, and this one is proportional with that. Okay? All right, so this is called a bow tie. Okay, so in a bow tie, we recognize this is similar with that, and that's similar with that. Okay, so this one's called a nested one, where we have one inside the other. Okay, so let's look over here. This is GE, so GE would be right over here, right? G and E. Okay, so which one would that correspond with? Okay, so if we're thinking about it, right, we got a small triangle over here, and then we have a larger one. So if this is this side of the small one, this side of the big one would be DE, right? I'm sorry. Whoa, what do we have over here? GE, okay, is proportional with. Oh, I'm sorry. So GE. Let's look over here. Sorry. So GE and DE. One thing is we have to recognize what they're doing here. So this is the small one, and this is the large one, right? If we have two different triangles here, we got a bigger version, and we have a smaller version, right? So this first one was the smaller version, and then this is the big one. So if that corresponds with that small one and the big one, so then the small one over here would be EF, right? So if that corresponds with that, right, what would correspond with DE? Well, just like you would think, it would be the whole thing, right? So the whole thing, which would be CE or EC, right? Either way, EC or CE. Okay, so that's what we're doing. This is called a nested one. So we're seeing that is two different triangles built in. All right, so then our last one. Enter the segments that provided that would make a true equation. So MN and MO. Okay, so MN, which is right here, and MO. Okay, so let's look at what would correspond with MN. MN is right over here. Okay, so think about this. Pause the video, see what you think would go over here. Okay, well, let's look at our hints. MN is between the one arc and the two arcs. So one arc and two arc would be JK. Okay, then MO. Okay, MO would be this right here. So it goes from, MO goes from the single arc to the one that doesn't have anything. So single arc to the one that doesn't would be JL. Okay, so that's what we're doing. We're just going to look at the on a bow tie like this. It looks like a bow tie. This is going to be proportional with this. This is going to be proportional with that. On a nested one, okay, so this side is going to be proportional with this smaller one, right? This whole big one is going to be proportional with this. And then when they're you have two angles, we just have to position itself correctly. All right, so go make sure you did those example we do's before you go on to the Delta Math. If you have a question, please let me know.